quickly tell me why Ensemble, when we already have enough algorithms, whole plethora of algorithms are available. So why Ensemble? Your take on that?
Yeah, good evening, Nitin. Good evening, Bharani. Good evening, everyone. Yes, Nitin. So I would basically bring up a very simple question. You can see my voice is a little different today. So I was sick. Now, when I was sick, I went to the doctor, and doctor said that, hey, you have COVID. Now, should I directly believe that person, doctor? He would be a very senior doctor, a very experienced doctor. But somewhere I know that I may not have COVID. I don't want to trust it. So what I would do, ideally, I go for a second opinion. Right? So same case, when you are trying to predict any value using any single algorithm, the probability of the predicted result going wrong is always there. Now, we generally speak about accuracies. So let me just try to share my screen and scribble something. Okay, so this is basically the mind map where you have all the algorithms detailed here. You might want to just go through this. You have classification models, then we have the shallow machine learning techniques, ensemble models, then regression models, right? So all these are documented here. You might want to just go through this. So whenever we talk about any algorithm, we generally say that the model is performing at XYZ accuracy. For example, if I talk about a classification model, we will say it's basically having a 95% accuracy. So when you use this machine learning algorithm and try to predict new data, let's say I have a single record, one record, and I'm trying to predict the result on this particular new record. The model's accuracy says 95%. But that also means that there's a 5% chance that this prediction might be wrong. How do I rely on such a model which cannot tell me that this particular prediction is correct? There's always chance of going wrong. So hence what we do is we resort to the ensemble techniques which improve the reliability. So what we do is simple logic. I will take machine learning model 1, irrespective of the accuracy. So let's not get into the accuracy point. I will try and predict this result on the new data using machine learning model 1. I'll get some result. I'll take machine learning model 2, machine learning model 3, so on and so forth, depending on the computational capability, the time frames that we have, the complexity with respect to the data and all that. Various factors we will include, and we will try to choose multiple models, and we will try and predict the results on the same record using all these individual models. The point is, if machine learning model 1 says, hey, this is 1, let's say student's case, it's pass, or COVID's case. This model says the patient has COVID. But this model says patient does not have COVID, then obviously there is some issue with one of these prediction models. So I will take much more list of many such examples, many such algorithms, and I'll try to do the prediction on the same record, and I will choose majority. The idea is single model may go wrong, but multiple models on the same data, the chance of going wrong is less. So we can improve the reliability of the predictions that we are making when you choose ensemble models. This is one practical application or why we use machine learning models, right? So this is one of the primary reasons. Of course, there are other benefits that we get when you use ensemble techniques, like it can handle imbalanced data better, it can handle missing data better, so on and so forth. Many such advantages are there. And while you choose ensemble techniques, like Bharani has mentioned, we have different ways to try and ensemble these models. So that's the reason, Nathan.
All right. Thank you so much.